On August 12, 2024, Prusa introduced an improved version of the Prusa MK4 3D printer called the MK4S. I've already talked about the Prusa MK4S in a previous video. Today, we are going to take a look at a product called the GPIO Hackerboard that was introduced to the world along with the printer. This add-on is actually much more interesting than it may seem at first glance. Before we start, I would like to say a few words. I bought the GPIO Hackerboard add-on in 2 pieces with my own money. Nobody has any influence on the content of the video and nobody pays me for it. If you want to support my work, you can do so by subscribing here on YouTube, on my social media, and by sharing my videos. In this video, we will be working with a product which is plugged into a printer motherboard. Improper handling can damage not only this product, but more importantly, your 3D printer. Everything you do is at your own risk. Let's take a look at the contents of the package. The first thing I have here is this label with the serial number of the board, which is larger than the board itself. Next, there is information about this board that will point you to the online documentation. This short cable serves as a communication cable to connect the X-body motherboard to this board. The X-body motherboard was in the Prusa MK3.5, MK3.9, MK3.9S, MK4 and MK4S printers at the time of filming. This board is actually only compatible with printers that have this motherboard. The highlight of the evening is this little board, which in the right hands can do wonders. Let's take a closer look at it. You may be wondering what is it and what it can be used for. This board adds 8 pins to the printer that can be controlled using G-code. It is equipped with a TCA6408A chip that serves as an 8-bit pin extender on the I2C bus. Pins 7 to 4 can be used as inputs and outputs. Pins 3 to 0 can only be used as open drain outputs. The open drain pin is controlled by a transistor that connects the pin to common ground when activated. When the pin is inactivated, it remains floating, which means that it is not connected to any particular voltage and any electrical noise can enter it. Electrical noise can also be picked up on pins 7 to 4 if they are being used as inputs. This can be prevented by using jumpers JP7 to JP4, which can keep the pins in the high state using pull-up resistors. The pins only work in digital mode, which means they are only in the state low, alias 0, or high, alias 1. Reading whether the input pin is high or low is not very interesting. What is interesting is the function that the printer firmware hides. Every half second, the pins set as inputs are checked. If the status on any pin changes to low, the printer will execute the G-code stored on the USB drive. This G-code file must be no more than 1024 bytes and the file name must be in the format btn_pin_number.gcode. On the USB drive, you need to create a folder macros and then upload the file to that folder. As you can see, everything can also be done using Prusa Connect, but you always need to delete the previous file from the printer. Of course, you can use an ordinary file manager. Pins 0 to 2 from the open drain section are also connected to this jack 2.5mm connector. The original purpose of this connector was for the ability to create time-lapse videos during printing. But there is nothing stopping you from using it as you prefer. If you are interested in learning how to create time-lapse videos during printing with this board, give this video a thumbs up, subscribe and let me know in the comments what camera you would be interested in the setup for. Next on the board is the SW aka switch pin, which really just tell us that the jack 2.5mm connector has been plugged in. By default it is connected to pin 0. When the connector is plugged in, it disconnects from pin 0. There is also an NRST pin that is used to reset the board, and an NINT pin that is connected to the TCA64088 chip's interrupt pin. In the printed document that came with the board are written limits of individual pins. Pins 0 to 3 can connect up to 24 volts with a current of up to 500 mA against common ground. Pins 4 to 7, set as outputs, can provide a voltage of 0 volts at low or 3.3 volts at high, supplied by the board itself. This is probably why their current load is limited to 10 mA. These pins can also be used to connect the ground, as with the open drain pins. However, it is recommended to limit the output voltage to 3.3 volts. Against common ground, the pins are connected in the low state. Pins 4 to 7, set as inputs, are set to accept voltage from 0 to 3.3 volts. Since this is an electronic component that is also connected to the printer's motherboard, when the printer is switched on, the connected board must be handled with great care. The pin spacing on the board is 2.54 mm. For my testing purposes, I soldered to the board 10 pins pointing downwards. In the most cases, however, you will want to solder the pins pointing upwards. This will make it easier for you to use this board in currently available covers, for example. The cable supplied with the board plugs into this connector on the motherboard, and yes, it is very short indeed. One way to route the cable out of the electronics box is through this hole. This allows you to use the board on the breadboard, for example. Another option is to enclose the board in this case, which protects the board from damage and you are not restricted in its use. If you want to hide the board inside the electronics box, you can use this alternative electronics cover. Unfortunately, the model available on the printable's website had a badly positioned hole at the time of filming. I recommend checking compatibility with your board if you decide on using the model. An alternative option is to use this board cover, which can be attached to the printer frame. This is also available in a version for printers with MMU3. This cover is mainly suitable for the first version of the board, which had the connector for jack 2.5 mm more extended outside the board. The new version of the board has this connector shorter. Because of this, I was unable to fully insert the 2.5 mm jack connector from the remote shutter release of my Canon R5C camera for time-lapse shooting. I've already contacted the author of this model and he has prepared a model for the new version of the board as well. I ended up choosing this option with the first version of the board and with the JP7 and JP6 jumpers connected. In order to better show how the board works, I decided to plug my second board into a breadboard. You can pass the G-code with the configuration to the printer using, for example, a file with a G-code extension. After uploading it to the printer and then run it, the board is configured and all the commands in the file are executed. For testing purposes, I decided to use direct communication with the printer using serial communication. I chose this method mainly so that I could quickly make changes to the board settings. I connected the printer to the computer using a regular USB-C cable. I used the CoolTerm application to communicate with the printer and run commands. To start using the board, I needed to learn a few G-code commands. Probably the most important one is G-code M262, which sets the pins to input and output. With the parameter P, we tell which pin we are going to set. With the parameter B, we tell whether the pin will be used as 0 alias output or 1 alias input. I already have a jumper on the pin 6, so I will use this pin as an input. And also pin 5. Pins 4 and 0 will be used as outputs. The state of the output pin can be changed to low or high using G-code M264. With the parameter P, we tell which pin we are going to set. With the parameter B, we tell whether the pin will be 0 alias low or 1 alias high. If you try to change the state of an input pin, the printer will warn you that the action is not allowed. This way, I set output pins 4 and 0 to low. Pin 0 is of open drain type and the pin is inactive in the low state. In this state it remains floating, which means that it is not connected to any particular voltage and any electrical noise can get into it. If I connect a voltmeter between common ground and pin 0, the voltmeter will show me the voltage that gets to the pin just thanks to the electrical noise. Pin 4 will show me 0 volts without any electrical noise. Everything changes when I set output pins 4 and 0 to high. Now the voltmeter on pin 4 shows me the voltage of 3.3 volts which the board gets from the printer. Pin 0 is connected to common ground in this state and therefore I can't measure anything on it. To measure something on it, I would have to measure against an external voltage source, for example. Using the G-code M265, the state of the selected output pin can be reversed. With the parameter P, we tell which pin we want to invert the state of. From the high state, the state will be changed to low, and from the low state to high. Pretty simple, right? The state of the input pin can be read using G-code M263. With the parameter P, we tell which pin is to be read. The result can be low or high. If you try to read the state of the output pin, the printer will display a warning. Pin 6 has a jumper, so it is kept in the high state. Pin 5 does not have a jumper, so it is in a floating state and its state is affected by electrical noise. So it is sometimes in low state and sometimes in high state. To get the low state, just connect the pin to common ground. To get the high state, use these jumpers or use an external source of positive voltage. You may have noticed that at the beginning I uploaded G-code for pin 7 to the macros folder in the printer. On the board, in addition to the jumper for pin 6, I also connected a jumper for pin 7. This was so that I could show you how the printer executes this G-code when the pin state changes. With these commands, I set the pin 7 to input and also read its state. Thanks to the jumper, the state is high. If I now connect the pin to a common ground, its state should change to low. This should make the printer execute that G-code file. The G-code to read the state of the input pin now also tells me that the pin is in the low state. After disconnecting the wire that grounds this pin, the pin will return to the high state due to the jumper on JP7. Plugging the wire back in between common ground and pin 7 will switch the pin back to the low state and trigger that G-code again. The G-code set on the pin in the low state can be executed even during printing. It can therefore be used to influence the printer's behavior even during printing. These G-code commands should be sufficient for most things you will want to do with the board. Now I will show you two commands that are intended for more experienced users. One G-code is M268, which can be used to read data written in the registry of our board. With the parameter R, we tell which of the 4 registers we want to read. Register 0 returns the state of the input pins. Register 1 returns the state of the output pins. Register 2 returns the polarity of the pins. Register 3 returns the configuration of the input and output pins. The return value is in the decimal system. For better understanding, it may help to convert this value to binary system. For this purpose, I have created a simple converter which can be found at the link in the description below the video. For an example, I can look at the register 3, aka the input and output pin configuration register. But first, I will set pins 7 and 5 as input and the remaining pins as output. If now I call G-code M268R3 to read that register, I get a value of 160. After inserting the value into the converter, I can see that only the checkboxes at positions 7 and 5 are checked and the rest are not, which corresponds exactly to our pin configuration, as I have only set pins 7 and 5 as inputs. The second G-code is M267, which can be used to override the register value of our board. With the parameter R, we tell which of the 3 registers we want to overwrite. With the parameter B, we tell which value in the decimal system we want to write to the register. The registers we can change include register 1, which overrides the state of the output pins, register 2, which overrides the polarity of the pins, and register 3, which overrides the configuration of the input and output pins. Note that there is no register 0, which contains the state of the input pins. The register is changed according to the actual state of the pins of the TCA6408A chip. To demonstrate the usage, I will use the value obtained from the previous reading of the input and output pin configuration register. Let's say I change my mind and want to use pins 6 and 4 as inputs instead of the pins 7 and 5. Using the converter, I just need to change the configuration and write the resulting value in decimal back to the printer using G-code M267R3B80. All G-code commands that change the board settings are stored in the printer's EEPROM memory and are retrieved from memory and sent to the board when the printer is restarted. You can find documentation for this board on help.prusa3d.com. Unfortunately, according to my tests and measurements, I encountered a lot of inconsistencies. At first I thought I had a defective piece of this board, so I addressed this with Prusa Research support. Unfortunately, despite all my and their efforts, we did not resolve the issues. Therefore, I again ordered a second board at my expense. With the new board, I tried the tests as with the previous board, but the results were the same. In fact, the original information on the website stated that all pins work as input and output. However, this was false information and the reason why I ordered the second board. Only pins 4 to 7 can be used as input, as we now know. In the printed documentation for the board are written limitations of each pin. Unfortunately, these limits were nowhere to be seen on the website at the time of recording. Otherwise, the documentation is quite usable but sometimes unnecessarily complicated to understand. It is definitely not the documentation that we are used to from Prusa. This actually brings us to the end of the video. Now, most of you are probably wondering what is this board actually for and why should you buy it? I will try to answer that in a future video. There is indeed many uses, but my time is very limited due to family reasons. So I don't have the opportunity to show you everything I would like to show you. If you would like to know how to work with this board, how to connect different electrical and non-electrical devices to it, and how to create time-lapse videos while printing, give this video a thumbs up and subscribe. Or drop me a comment below the video and tell me exactly what you would be interested in learning about the board and what camera you would be interested in setting up for time-lapse videos.